Okay, so welcome to week 2, everyone. I know some people are out today because of exams, so if you're watching this recording later, uh, thank you for watching it. But yeah, we're going to be building off a little bit of what we did from last week, kind of, strengthening that foundation for your sketches. Um, so yeah, let's just get into it. Uh, so we're going to be going into more intermediate design skills. And one of those things is something that we call constraints. So last week we touched a little bit about it, or I talked a little bit about it. I used it in some very specific scenarios. But today we're going to kind of go over more of the different constraint types. And then we're going to kind of practice them just so you know how to use them. Because constraints are very important when you're making your CAD designs. So obviously, these constraints are tools to help you constrain or define your sketch. You've been using the dimensional constraint with the smart dimension tool, or the dimension tool. I forget exactly what it's called, but you've been using that. But you can do other things called geometric constraints. So, if you take geometry class, which you've probably taken already, you got like the parallel, perpendicular, all that fun stuff. But then there's a couple more that are a little bit more relevant to when you're CADing stuff, specifically like collinear, concentric, and coincident. Coincident's kind of a new one if you haven't CADed before, but it's mostly just like merging 2 points or a line and a point together. It's just kind of making two things on top of each other, which can be useful. Collinear, taking two lines, putting it on the same thing. Concentric is nice, making all the circles centered at one point. And then, there's other stuff. You will see that there is the fix and unfix constraint. This is something I usually recommend that you don't use like at all. We're going to teach you how to use it just so you know how to use it. But the reason that I encourage you not to use it is because you can lock something that's like kind of arbitrarily placed and make it fixed, right? And when you are making something and you want it to be nice and precise, if you lock in an arbitrary constraint, it's not really the best practice, right? Usually there is going to be some way that you can define your lines and arcs and points with the rest of the constraints to make it fully defined so that you don't need a fixed or unfixed constraint. I think the only time I've actually used it is when I was making like a pulley with involute curves, which is a very like specific and like complicated thing because you're using like an equation to draw a line, but you're most likely not going to need to use the fixed or unfixed constraint in like 99% of scenarios. So yeah, we're teaching it to you, but please like don't use it. And I'll know when you use it because you'll kind of see. But yeah, there's some more here. Horizontal, vertical, kind of self-explanatory. Tangent is what we used last week on that game piece to kind of make a smooth transition from that line to that arc. And equal, making two things the same, symmetry. I think there's a couple more, but you kind of get the idea. So what we're going to do now is we're just going to download this worksheet that I sent to everyone on the Discord. We're going to open it, and then we're going to follow the instructions on this sheet. So I'm going to go into the Discord here. It should be under resources. Okay, it's there. So you open Fusion. I recommend you open the data panel. And then there's this upload button. You can drag and drop or select the file. And then I'm just going to open it. So Oh wow, that's bad. Thank God I got a ThinkPad.
Yeah, put that in.
What's up?
You would need me to grab your blouse.
Yes, please. That would be great. Okay. All right. Raise your hand if you're not here yet. Okay. Take your time because I just spilled a drink on my laptop. So I'll be right back.
My experience would be cut right now.
Yeah. Oh. What am I doing? Oh,
Tragic, dude.
it's tripping. It's so funny. I have like phantom clicks. It's a touch screen too.
That happens.
Okay, hopefully that's. I did not want to open that. All right. Okay. Who needs more time? No? Okay, cool. I guess I'm gonna wash this sweatshirt later. I'm just gonna wash my sweatshirt later. It's fine. I'm no longer.
Use your sweatshirt?
Yeah.
Bro.
It's fine. It's fine.
It's so
Okay.
tragic.
It's okay. I just washed it too. Oh, it's fine. All right. So now that we have this, what we're gonna do is we're gonna edit the file here. So you can see in the timeline, we have like this image that was inserted, and then this plane, and then lastly, there's this sketch here. So instead of creating a new sketch like we've been doing before, we're gonna edit this one. So you can right click and edit the sketch. And now we can manipulate these lines, right? So basically what we're going to do is we're just going to kind of follow what it says. So I'll do a couple of them and then let all of you go and try to do it on your own. And if there's any confusion, I'll just kind of go over the ones that people are having the most trouble with. Okay, I'm going to hide this. But you can see here, there's text. It tells you what to do. So you want to make these two perpendicular, right? So right now, you can drag these around. But you can apply a geometric constraint by using this toolbar up here, most of these red icons. If it doesn't have what you're looking for, you can click the constraints button and then it'll drop down with more stuff. But for here, there's that perpendicular constraint. You can either press it before or after you select the lines. What I like to do is I usually just hold shift and then I click both of the things I want and then I apply the constraint, right? Just like that. But you can also do it the other way by selecting the tool and then selecting like the geometry, right? So for this, we want all three lines to be parallel. So I can go into the tool here, the parallel tool, and then click two lines to make them parallel, and then click the other two to make them parallel as well. Keep in mind, if you want to like select something else or like a different tool and you're still in like another tool, you typically have to press like escape to exit the tool. So that goes for all of these geometric constraints, but also like that dimensional or the sketch dimension constraint. Like sometimes people last week were trying to drag like circles and stuff around, but they couldn't. And it was mostly because they were in the dimension tool. So you need to make sure you exit the tool that you're in, so you can, use your mouse to select stuff. But yeah. So I did these first two. Um, I'll just give everyone about like 5-10 minutes to work on the other ones, and we'll just walk around a little bit, help people out.
So I have SolidWorks. How do you look at the old constraints that you found on here? Because I accidentally made these. Check with I also had some that I've gotten. That was kind of weird. How that was on the problem before, but. Because I'm selling them. Oh, yeah. But like you have to like have it like wait on since. So it's like for me it gets to the point where I usually get out of nothing. It's opening. Yeah. In my opinion, solve it a lot better. Yeah. Funnily enough, I know Cam in Fusion. Okay, I heard Fusion is good. Yeah, it is. We had this ancient composition, we had this ancient you can use that CNC routing. And yeah, it only Fusion exported in the correct format, so we have this exported to Fusion, and then my friend. And then your once those are fixed, you're then you use by tangent to make. Yeah. They're good. That's okay. Yeah, but I can't say that. Like, yeah. What's that? Still zero, but. The so you have to use the fixed constraint first to make sure that the circle doesn't. That first, that will block the edge lines. And then now should pull. Yeah. And then you edit the sketch, so you're not making. So that's like that's like something yeah. Who's in the other one? Yep. I've already done it, but I was really you're supposed to take one to read it. Okay. Yeah, I totally do that. Yeah, so you do inches, but it's not on the order, then the 2 inches, just double click that one and edit its speed. That's all I'm asking you to make that one 2 inches better. Very happy. Very happy. Yep, you're good. I love it, I'll put there. Yeah. For some reason, the Fusion like constraint is like very ambiguous.
Yo, so.
Skateboarding. Yeah, and then we just drop down schedules. Interesting. Okay, so there's a new sketch that's started. That would. So I have it online. Yeah. Click on that one. The other one, sorry. Yeah. Thanks. Right-clicking. Leave all. Okay, yeah, okay. Now, double click into that one. Now try it. Yep, of course. Oh. So for this one. If I want to do number three, like the same size, they're like the color.
What you could do is instead of fixing like the diameter, you can fix the center, and then those would this would change.
Oh.
Like the diameter would change. Yeah. But then you would also need to like constrain the center of that circle spaces. Because that one.
Those are really. But that one before the.
Okay. So some people were asking me about this third one. Is anyone confused about this one still? Okay. Yeah. So it says here to dimension circle number 3 with a diameter of 2 inches. So this like circle with a line through it is the diameter symbol. And then it's 2 inches. So you want to set this to 2 inches with the sketch dimension tool. Then it asks you to fix circles 1 and 2. So you're going to use that fixed constraint that you shouldn't be using like anywhere else. And then you click on these 2 circles, right? So when you click on them, you can see they change color. So if I ever see a sketch with like this green stuff, then I kind of know you added a fixed constraint. So hint, hint for your homework, don't do this because I will know, right? So again, this is for demonstration purposes for this assignment, but you shouldn't be using it. So yeah, these 2 circles are now fixed. And then I will apply the tangent constraint from circle 3 to 1, and then circle 1 to 2, or 3 to 2, just like that. All right, so all of this is now fully constrained, even though these 2 are kind of arbitrary. The other thing for circles, when you fix them, you can also choose to fix the point in the center instead of the diameter. So if you do that, like the center point will be fixed, but the diameter won't be fixed. So that's just something to know. But at the end of the day, you probably aren't going to use this constraint tool very much. Yeah. Is there anyone else that has, or like that wants me to demonstrate another one of them? The very, like the bottom right one? Yeah, okay. So there's technically like 2 answers to this question or this example. You want to align the centers of the circles on the same horizontal plane, right? So you can kind of line them up in a line, or you can make them all concentric. The concentric thing is like a technicality because if they're all centered on the same point, then you know they're on the same horizontal plane. But I would say like the technically right answer or more right answer is to kind of have them all in a line. What I've seen people do is they've drawn a line and then constrained their circles to that, but you can do it without a line as well. So there's the horizontal vertical constraint. In many other programs, like this constraint is separated into two different constraints, but Fusion wanted to make it more compact for some reason and did it in one, right? And one of the, I guess, like downsides to that is that you kind of have to like encourage the CAD to do exactly what you want, because it's going to take the easy way out and constrain to the more easy axis, if that makes sense, right? So if you look at these two center points, to make them horizontal or vertical, Fusion will choose the easier one. So right now, I'll do it like over here to be a little bit more clear. But you can see here that these 2 points are closer to be vertical than they are to horizontal, right? So if I apply the horizontal vertical constraint on the two centers, it will snap to be vertical, right? And, you know, in this question, or it asks it to be horizontal, so that's not what we want. So I'm going to undo this. And then I'm going to encourage Fusion to do what I want. So what I mean by that is I'm going to move this circle to be closer to be horizontal. And then when I apply the constraint, it'll do what I want, right? And same for this one. This one's kind of already where I want it to be. So when I apply the constraint, it is in a line and it's not going vertical. So this applies for like the horizontal vertical constraint, but it also applies to other things like the tangent constraint, because you can technically have a line be tangent on one side or the other. So sometimes you need to encourage Fusion by dragging the unconstrained areas of your sketches to be closer to what you want. So yeah, that's also kind of why I tend to draw things not exactly where I want them to be before I constrain them. In my mind, it works a little bit easier because if it's close and then I apply the constraint and it moves to where I want it to be, it can kind of help me visually confirm that I applied the right constraint. Because sometimes you might have a part or a line that's where you want it to be, but it'll be missing a constraint and it won't be fully constrained. And you'll be like scratching your head because you're like, yeah, this is where I want it to be, but it's not constrained. So then you have to go and find out what's missing. So to eliminate that confusion for myself, I typically draw like everything a little bit like quote unquote wrong, but then once I apply the constraints, then it becomes right. If that makes sense. Yeah. Is there any other one of these that I should go over? You can just yell it out. It's not a big deal. Okay, sure. So equilateral triangle, you know, you just want to make sure all of the lines are the same length. So I'm going to be using the equal constraint here. I'm just going to select 2 lines, and then I'm going to select another 2. So just keep in mind, you typically select 2 things at a time. So if you want like more than 2 things to be the same, then you typically have to do a couple different operations. Though sometimes I think you can do them all at the same time. Yeah.
Another thing you might want to show them is like after I had a problem with someone, they did a bunch of others, but if they did something else wrong, they could figure out how to delete the one specific constraint.
Okay, yes, that's a good point. So some people, or like this will happen like regardless of how good you are at CAD, you'll at some point accidentally make a constraint that you didn't want to make, and then you want to undo it. And sometimes you've like done other things afterwards and you don't want to control Z everything. For me, sometimes if it's too annoying to find, I literally just delete the line or the arc and then I just draw it again and reapply the constraints. But there is a way to remove the constraints in Fusion. It's just sometimes a little bit hard to see. So to do that, you want to make sure you're in the selection tool, which is like making sure you're not in any of like the equal or the dimension constraints. So I'm going to press escape, make sure I'm in the selection tool. And then you're going to hover over the line or the arc that, you know, has the constraint that you're looking for. So when I do that, if I hit the right spot, you can see these little equal signs are popping up, right? So this equal means, you know, the same length. But if I do, you know, something over here, if I can find it, there's like a perpendicular constraint right here. This is the coincident constraint because this line or this point on this line is coincident to this one. But there's also a perpendicular one somewhere in here. But
Does right clicking do anything?
is it? Not really. I repeat equal because I just use equal.
Lame.
Yeah, I don't know. So you can find it, but for me, I usually just get annoyed and I just delete the line. I think it's faster, so I would recommend that for you, so you don't spend like a long time looking for the constraint. Especially when you get used to applying constraints pretty quickly, it's usually a lot faster to just delete the line and make it again. So yeah, it is there. Like, you know, this parallel one, it's right there. This coincident one. But yeah, it is there. But I usually just skip it. Any other questions? Okay. So just so you know, you're going to be doing this like a lot. So you want to get very proficient at this because this is probably like the majority of what you're going to be doing when you're CADing stuff. I can open up some of my old sketches from like my other projects. Wait, I can do it right now. Like this is my toy design project from last semester. Where is it? So this is a little bit more advanced, but I basically used this base sketch as a foundation for all my solid parts later. You can see there's like there's a lot going on, right? But maybe I'll do like these wheels. Where is it? Yeah. But you can see these icons here, you know, a bunch of tangent circles, a bunch of dimensional constraints, but there's a lot of geometric constraints as well, right? And the power of all these geometric constraints is that I can limit the number of dimensional constraints that I have to be able to make changes easily, right? So for this like project, we didn't know how big the chassis was going to have to be to fit everything inside. So this sketch made the design very easy to change. So like if I was like, oh, this needs to be longer, I can change this dimension. And then because all these solid parts are related to this sketch, they all like changed with it, right? So this is a very like complex use of sketches, but you can see how much power and utility you can get out of them.
It makes them visible. So
Yeah. But then like this one is already enabled, but you
No
can't
shit,
see
really?
it. But I think maybe it has to do with the canvas. Yeah.
Oh, it's just
Makes it easier to see.
Blend in.
Yeah.
Mm-hmm.
So they are there. It's just sometimes they're hard to see. In other programs, sometimes you can select a line or an arc, and then on the side it'll tell you all the constraints that it has. I found that to be like really useful, but that's not really a thing in Fusion, so I usually just delete. But yeah, does this make sense though? This is a very like complex use case, but I hope that makes sense on how like you can utilize really good sketches to make nice designs. Okay. Does anyone need any more time on this? Okay. That's basically a free 5 points if you're finished. So, yeah. Okay. So, now that you have a taste for geometric constraints, we're going to be using that and a couple more tools to make more advanced sketches. So in this case, we're going to be making a simple gear with a threaded hole in the middle. So we're going to start by making that gear profile. You can see kind of a preview of what the sketch is going to look like. You can there's only a couple dimensions here, but you can see everything is fully constrained, right? Everything is black, since I think the default on Fusion now is the dark theme, so all your lines will be white, but you know, the same principle is there. It's just the color is different. So okay, so I'm making a new design, new part. I'm gonna hide this again. And then I'm gonna create a sketch, just like we've been doing for most of the stuff. Picking a plane, and then I'm gonna start sketching. So to make our base, we're gonna have, you know, some kind of circle, and then I'm gonna be creating a partial tooth profile, kind of similar to what we did on the game piece yesterday. I'm gonna be making part of the tooth, and then I'm gonna have Fusion do the rest for me. So I'm gonna mention this, and then I'm gonna do this angled line here. It's kind of line going over here, and then a line going to the center, right? So here again, I'm purposely making the lines kind of off from where I want them to be. So I'm gonna apply some geometric constraints to make it more specific. One other thing I'm gonna do is I'm gonna change this long vertical line into from a solid line to a construction line. So construction geometry can be really useful because you're basically creating more reference points for yourself that Fusion will ignore when you go to extrude stuff or like revolve stuff. So I'm gonna make it construction by right clicking it and doing normal construction, or you can press X, or there's this construction button on the side. So there's a bunch of ways of doing it. But yeah. So now that I have that, I'm going to apply some more geometric constraints. I want this one to be vertical. So horizontal, vertical. This one, I want it to be perpendicular to this vertical line. So I'm going to do that real quick. And then the rest, I'm going to fill in with dimensional constraints, right? So I'm going to do like a vertical dimension here. I'm going to specify this as like 3, maybe more. And then I'll specify an angle right here. So you can see, now that I've applied those constraints, this tooth is fully defined. It's all white now, or if you're in the light theme, then it's all black. So that's what we want to see. Obviously, for a gear, all these teeth are going to be identical, right? There's very rare cases where you don't want identical teeth. For the most part, they all should be the same. So what I'm going to do is I'm going to use the mirror feature and then the pattern feature to basically duplicate this profile I've created. So we have this half tooth. I want to make it a full one, but because, you know, a tooth is symmetrical along this line here, I can just copy it. So I'm going to hold shift. I'm going to select these 2 lines, and then I'm going to mirror it. So you can see this triangle looking tool here has this mirror function. If I click it, it'll ask me what line I want to mirror it over. So I'm going to mirror it over that construction line we made earlier. It'll give me a preview. It looks good to me. And I'm going to press OK. So now we have this nice finished tooth profile. Raise your hand if you need more time. Okay. Wait, do you just want me to do it again?
No, I just have a quick question.
Sure.
How did you do that angle constraint? Or the,
Oh, this one? Okay, so for the angle one, you just use the sketch dimension tool, and then you click on two different lines. So I clicked on this top one, and then this angled one, and then you can apply it. Okay, so I'll do the mirror again. So you can see here, there's this vertical line that I want to mirror across, and then these two lines that I want to copy. I'll do it a little bit differently this time, just to show you that there's different ways. I'm going to click the mirror tool first. You can see here under objects, it'll ask me to select what I want to be mirrored. So I'll select these two. And then I click mirror line over here to specify the line that I'm going to mirror across. Just like that. Okay, I'll just walk around. Again, so Eden is making a decision.
Value?
Yeah.
Andrew?
Oh, you're selected on. So practice. The numbers don't lose. But also apply. For me, the number.
Side, just the edge now. Yeah.
You can see it turns black.
And then you use dimension it. It just applies with that. That's how you apply it. You have to use your. So it's a dimension. This case. I see. Yeah. So now. That's quick move there. Like this again.
Yeah, so if you try to
It's whatever. That's not too. This is like. And then you create.
can see
And then, so then you got your. So you went to an hour and and decided that you and then you're not valued and yeah, so that's why we started it. And then, so what he did, so he did the reference, but it wouldn't. Now, he says, but it won't impact the fee. So now, what I did is that.
You still haven't. No. You got a lot.
And now that's. To enter.
Mirror like people wait for the people. Okay, okay, come on. I think the values is really nice.
Yeah. You can skip. Yeah. It's fine. Cool, it's fun. Oh. Oh, yeah. So if the thing like disappears on you, what you can do is on this sidebar, it just sketches drop in. So this is helpful if you have a bunch of sketches overlaid and you only want to see specific ones. So like, so they're still there, but you won't be able to click on or see them. And that. Yep.
Who needs more time on this? Okay, so now that everyone has this nice tooth, what we're gonna do is we're gonna do something called a circular pattern. So again, most gears don't have one tooth, right? So we want to make a bunch that are all the same. So what I'm gonna do, instead of doing a mirror, and you go under the create drop down, there's a circular pattern tool. I'm gonna select, all these lines that we just made. We're going to choose a center point, which is just the center of the circle in this case. And then we can specify how many copies we want. So I'm going to just make this like 10 or something. 12 looks good to me. But once I press OK, you can see it generates a bunch in a pattern. They're all equally spaced, so that looks good. But the nice thing is that because they're all based off of the original tooth that we modeled, if we make any change to it, they're all going to change with it, right? So if this is, we decide that this should be 80, then all of them change, right? So it's kind of us being a little bit lazy, but it's also us having the foresight that, you know, similar related parts should be changed together, right? So that's kind of what this circular pattern tool is, and what the mirroring does is, you know, this half of the tooth is identical, just mirrored. So we can just create a couple of dimensions here and create a more complex part that is very easy to change. So, you know, I can change this angle and then all of them will go with it, which is good. All right. So the last thing I'm going to do is I'm just going to trim away at some of these extra areas. You don't have to do it. I just am a little bit lazy when it comes to extruding stuff, and I want them to all extrude from the same face or from the same like closed body. So I'm going to do trim tool, trim all of this stuff away. Oops, I trimmed the wrong thing. Okay. So now that I've trimmed it away, you can see, you know, whenever I highlight my mouse over it, all of it kind of lights up, which is nice. The other thing to note is, you know, if these weren't construction lines, if I turn them off, you can see how all these bodies are kind of separate now. It's because, you know, these construction lines kind of get ignored when you go to extrude and revolve stuff. So I'm going to make those construction, and now the whole thing lights up. So I'm happy with this. I'm satisfied. I'm going to finish this sketch, and then I'm going to extrude it. It's good. And then boom, we have this nice gear here. Anyone need more time? Okay, I'll wait like a minute or two. I should low-key just come here and just like study before class.
Okay, well, before this class, I was looking for a class. It was kind of out of the way. I thought you meant like normal classes.
Oh, no.
I had nothing better to do. I wouldn't have had to move my car if I was in a time. I read as I parked, I was like, I'm going to park at Kodak. It was too late. I didn't want to move my car because I was already behind I wasn't going to be late to class, but I was behind my schedule.
Yeah.
I typically like to get to class or to get to my first class around 20 minutes early just to download minutes or chill or whatever. Be there and like zone out for a few more minutes before I gotta walk in.
I'm throwing in the towel and I'm sending my car to a mechanic because I don't want to fix it because it's too cold to fix it outside right now.
Look at that shit too, don't you?
I have AAA though, so it's fine.
Okay. So what of it is like not functional?
It doesn't start.
Oh. Nice.
I think it's like an electrical or a vacuum leak because it was running when I pulled it into the garage and I started working on it, and I fixed another issue. At least I think I fixed it, and now it doesn't start up.
Does your starter go out? Or just starter?
No, the starter works fine. It just doesn't idle at all.
Is it a manual?
Yeah.
I had nothing for you there.
But I think it's either a vacuum leak or there's some sensor deep in the car that I accidentally unplugged and I didn't plug it back in.
If it's immovable, I'd say if it's a sensor, you can just take it to AutoZone. They have that diagnostic tool they can use for free.
Yeah,
But you can't move the car.
I can't go anywhere. I think it's probably a vacuum leak.
This
but
is
I
an
need to,
excuse to buy that diagnostic tool.
I actually have one.
Use the diagnostic tool.
Dude, it doesn't help for this. I think it's because if it's a vacuum leak, it's not a sensor issue. It's just something. It's just
True.
I got a smoke machine to detect vacuum leaks, but it's too cold and I don't want to
Yeah.
go outside. And my car's still covered in snow. Like,
In the garage.
no, it's on the driveway right now, and I'm not trying to work on it right now with like it covered in snow.
Whose driveway? Because you're in that apartment, right?
No, I live like in a basement at a house, so I have a.
Well, I went and picked up that part you printed for me. You were at the
Oh, I was at my friend's house. My printer was at my
right.
friend's
You
house.
said
Yeah.
I forgot.
No, you're good. Okay, does anyone need more time on this?
They're all bad.
Try that. Okay, so the last thing on this one is using the hole tool. I'm going to go on kind of a rant about why the hole tool is important, but you'll kind of see in a little bit once we start using it. So typically when you design a part, you're not going to be the one manufacturing the part, right? I mean, if you like machining things like I do, sometimes you'll do it. But, once you get your big boy engineering job or whatever, you're typically going to be sending off the part to be machined, right? And you want to basically give the machinist as much information as you can so they can make your part in the way they want it, in the way that you want it to be done, right? Because you don't want to give them a part, then they'll interpret something wrong, and then, you get the part and it's not what you asked for, right? That, or they may charge you more for something that you didn't need.
Or they won't even do anything if there's not enough clarity.
Yeah, or they might just reject your part, right? So the hole tool is really important because it gives the machinist information on, all the specifications of the hole. Like you can write it manually, but that is kind of annoying. And it's typically a lot easier just to use the hole tool. So especially when you get into more complicated holes, you're like, oh, I want a counterbore this deep with the bottom having threads for like this certain bolt, right? when I'm CADing by myself, sometimes it's kind of bad practice. I'll just kind of ignore the hole tool and I'll just like make an extruded hole, right? Especially for something that doesn't have threads in it. It's sometimes a lot faster just be like, oh yeah, sketch here, I want a circle here, you know, add some dimension, like, 30, and then I'm gonna like extrude it and then call it a day, right? Like that was fast. Oops. Well, now it's less fast. But like this was pretty quick, right? But the problem is you might lose a lot of information, right? So depending on what this thing is for, it might have some specification that you need to specify later. And it's a lot easier if you just call it out when you make the hole tool. Like for example, if you're making a hole that has a dowel pin connection, you're going to use like a metal pin and you want to specify, the exact type of fit for that dowel pin. You can do that in the hole tool. So it's really useful and it conveys a lot of extra information that you might be losing if you just use, a sketch and an extrude. So that's why I kind of stress using this tool when you're, designing things, especially to be made for other people. Because they can use that information to create their like programs for their machines to make your part. This is especially useful because I guess it's a side tangent, but Fusion has other like integrated things, including CAM, right here, right? So if you use the whole tool in Fusion and then your, machinist also uses Fusion, they can open your Fusion part and then they can, make their CAM program and then it'll automatically detect when there's a hole using the hole tool, right? Because, you gave that information to the machinist, they're going to be like, oh, there's a hole there. It needs to be this specification. And then, they might have their own profiles for that certain hole, right? If you just have an extruded hole, a CAM program might interpret that as something called a pocket. So instead of using a drill bit, they'd use something called an end mill, and that takes a lot more machining time. So your part might get a lot more expensive if you don't specify that it's a hole or not. So that's a little bit of like extra information for you, but there is a reason why we ask or why we teach you these things. So I hope that makes sense. But yeah, so we're going to use the hole tool. I'm going to enter the hole tool, which is right next to revolve. And then I'm going to specify kind of a point here. So I'm going to place it on like this face. Sometimes you can like make a hole tool or use the hole tool in relation to like a sketch, but I'm just going to be a little lazy today. I'm just going to kind of select the middle here. So I'm just going to put it in the middle like that. But you can use a sketch with like points on it, especially when you're doing lots of holes. That can be pretty useful. But you can see here, all this information is stuff that you could have lost if you just used the like a sketch and an extrude, right? So you can see, you can specify the type of bit, like the diameter here, even the taper angle on the drill bit. The depth here isn't super important because we just want it to go all the way through, but you can add depth here. So I'm going to set it to all. But like, this is another like little nitpicky thing. But if you did like an extruded like sketch to some desired depth, it's usually going to be a straight hole, right? The bottom's not going to have a taper, but almost all drill bits that you would use will have some kind of taper on it, right? So that taper is modeled into, your hole when you add it into Fusion. This is a really thin part, so it's kind of hard to tell, But if I like change the depth to like 5 millimeters, oh, that's the diameter. If I change the depth to like 5 or something, you can kind of see there's that taper on the bottom, right? So that's, a little bit more information for the machinist, but also for you, right? If you have a bunch of features that are super close together and you kind of forget about those tapers when you're making extruded holes, you might have material missing that you needed. So this is all like important information to the person designing it, but also to the person machining it. For this, I'm just going to go all the way through, so you're not going to see it. But you can see there's a bunch of other options, right? So there's like counterbores and countersinks, but then there's also tapped holes. So in this case, I want a tapped hole. You can specify, the kind of threads that you want here. And you can see there's a lot of information here that you would miss if you just modeled it. So this looks good to me. I'm going to press OK. And you can see we have some nice threads here. The other thing is, like, if you tried to model a thread yourself, it's a really big pain in the butt because you have to model the tooth profile or the thread profile, and then you have to draw a helix, and then you have to like pattern that helix, right? That's a lot of work. So, if you just want simple threads like this, it's typically a lot easier to use this tool also. But yeah, I hope my long rant makes sense to you. But yeah, it's a very long explanation of why you should use this tool. But this part is finished, so if you take a screenshot of this, you should get full points. Does anyone have any questions about this? I can try to pull up like drawings and stuff.
So I'm hoping for sketches because the annotation tool puts a.
Yes, yeah.
But sketches is kind of the scope of this.
Yeah, I can open.
I was looking at other common things that would make more sense on the manufacturing one because like threads are pretty visual in this sense because Elizabeth thinks three big threads is a heinous idea.
Yeah.
I do.
Okay, so this is kind of a good example. These are actually some parts that I was designing for a company actually. But these are something called part drawings. After you design it, you make these and then you send them out to a manufacturer. If you're interested in this, you should take the GD&T course because that's kind of what they go over. But you can see here, like, I have holes here for dowel pins and stuff like that. And, I use the hole tool. I use a different software. I use SolidWorks. But when I click on this hole, when I'm creating my part drawing, it already gave me all this information, right? I think I only had to add the H8, but all of this was already there. So it's a lot of, nice information for the machinist to know, and it kind of speeds up the process when you create these drawings, right? You can see here, you can see the taper with like the section view and all that stuff. So, these callouts can get pretty extensive. So it's a lot faster if you just create that callout when you're designing it. Especially because these numbers will change if you ever change like the dimension or whatever in your model. So yeah, it's fun stuff. Now you all have to sign an NDA. No, I'm just kidding. But yeah, any other questions? Okay, sweet. Okay, so I think the last one for today is this hair dryer. You can see here kind of the process on which we're going to go through to make this. We're going to use something called a loft. We're basically going to create a couple very simple sketches on different planes. And then we're going to use the loft tool to create a solid body that follows all of these profiles. So, yeah. Are there any questions before I start this one? Okay, cool. Okay, so instead of starting with a sketch like we normally have been doing, what I'm going to do is I'm going to create more planes. So let me try to show this. So you can see with, every new part that you create, Fusion automatically generates 3 different planes for you. But there's often times where you might want to create more based on either, existing geometry or just based off some dimension that you have in mind. So to do that, there's this construct feature over here, kind of close to the middle, and there's a bunch of different things that you can use. So I'm mostly going to be using the offset plane and the mid plane today, but you can see there's a bunch of different options. One of the cool things you could do is like if you're maybe reverse engineering a step file, or you have some holes that you want to reference and create a plane. Sometimes I would like make an axis through 2 holes and then make a plane that's like connected to those 2 axes. So it's a nice use case depending on what you're doing. But I'm going to keep it simple. We're just going to do some offset and mid planes today. So I'm going to start with an offset plane. I'm going to reference kind of this top plane here. Just because, the hair dryer is going up in my mind. You can use any other one, but this is the one that makes the most sense. I'm going to specify a distance here, maybe like 30 something, maybe more. And then I'm going to create 2 more. So you can see there's 4 circles here. I'm going to create 2 more planes. So I'm going to do another offset plane. I'm going to make this one considerably farther. I'll do like 100 or something. And then for the last one, just to show how it works, I'm going to do a mid plane. So for the mid plane, you select 2 planes, and then it just creates one in the middle. So, yeah. Now we have these 3 extra planes. I'll give everyone like a minute or 2 to catch up.
Yes, it is. He's like that. I'm sure this is whatever you want. Frequency. You can put that on. And then I'm still putting the bottom. If you want to put that one, you're putting on offset. And then that's some smart. So. No, what? Less. Let's say it. There's like a sheet.
All right, so now that we have these planes, I'm just going to draw a bunch of simple circles here. So you can see it's nothing too crazy. I'm just going to make sure they're all centered at the origin, so they're all like co-linear with each other, like the center points are all collinear or concentric.
Interplanar concentric.
Yeah. I don't know, maybe like 80. So I'm going to create 4 separate sketches. They're all on separate planes, right? So we're going to create a new sketch on top of, or on the new plane that we created. We're going to change this size to be a little bit different. Typically, I like this one to be a little bit bigger. I'm going to make another sketch. Typically like this one to be a little bit smaller. Maybe not that small. And then I'm going to make one more sketch. Okay, this one's a bit small. Okay, so you should have a stack of circles that looks somewhat like this. Raise your hand if you need more time. Okay, no worries. How much caffeine do you think I still?
Probably exclusively. Probably a little bit more than that. Probably lost like 30.
That's so sad. So the plane, I know, is table. We're going to draw right now. That's just kind of instead of
Okay.
Yeah.
Thank you.
size? I would make it. Oh, for.
And do that to
Oh,
Yep.
Oh.
Okay. So now that everyone has this, what we're going to do is we're going to create our loft now. So go under create. There's this loft tool. Again, when you hover over it, it kind of tells you what it does. The loft tool is really nice for making things look pretty, especially when you have something or two shapes that don't necessarily connect well with each other. Obviously, right now we're doing a bunch of circles, but you can see here it like transitions this rectangle into a circle, and the parts can typically look kind of nice. So for the loft, you want to select the order properly. So you kind of want to go like linearly. Is that a word? Linearly in a line with you know, each profile that you want to do. So I don't want to select like this bottom one and then this kind of one in the middle and then this one, because then it'll like invert and like make the loft inside out. So I'm going to do it wrong just so you can see, right? So I'm going to select this one and then like I'll click this one and I'll go back up. You can see like it's all like inside out and corrupted and stuff. So I don't really like that. So I'm going to go back and select them in order. And then there. So now we have like this vase looking shaped thing. Yeah. Okay. So I'm gonna hide the origin. Now that we have this, I really want to hollow this out, right? So you can see here, we're gonna hollow out the inside. To do that, what we're gonna do is we're gonna use a shell tool, which is over here. And then I'm gonna click this face. So the shell tool is cool because it'll create like a constant thickness throughout your part. So, you know, this loft is a very organic shape, but if I just use the shell tool, it'll make sure it has a constant width, or the walls will have a constant width. So, I don't know, I'll do like 4 or something. So when I apply that, you know, we have this nice looking vase that will become a hairdryer. All right. So the next part, you can see here in the slides, we apply this fillet. So similar to that hammer that we did last week, we're gonna round the corner. I'm purposely gonna do the fillet incorrectly to show you like some dependencies in a little bit. But what you're gonna wanna do is to apply the fillet to the outer edge only. I'm gonna apply it to both the inner and the outer edges to show you what happens. But that'll become relevant a little bit later down the line. So I'm going to make a fillet here. I'm going to select the outside and the inside. You should only be doing the outside, but I'm going to do both. So we have this, it's nice and rounded. And then the next thing we're going to do is we're going to add this handle. So I think the slides are a little bit different from how I prefer to do it. I typically like to make the plane to be like beyond the body of the hair dryer. So I'm going to create an offset plane here. I'm going to click on one of these, and then I'm going to drag it out to be past this face. So you see here my plane is beyond it. Looks good to me. And then I'm going to create a sketch on that plane. So there. I'm going to make a circle. I'm purposely going to make it off-centered to apply some geometric constraints. You can see here, like because I drew all of these circles on the origin, this like origin point is also centered on this plane as well. So that's kind of one of the other reasons why I recommend you have everything off the origin, because it's typically useful when you create parts with more than one feature on them to kind of use it as a nice reference point. So I'm going to make these 2 points vertical. I'm going to specify a vertical dimension here. I'll do like 40. I'm going to add this diameter. So do that maybe like 45. And then I'm going to extrude this. So this extrusion is going to be a little bit more complicated than before, because instead of the direction being one side, I'm going to have it as 2. So you can see there's 2 arrows going in different directions, and we can specify different parameters for each of them. So for side 1, which in this case I think is the blue side, it's going towards this hairdryer body, but I want the extrusion to go right up to the face, right? If I just add some like arbitrary number here, and I set it to join, you can see how like part of the cylinder that I'm extruding is kind of inside the body of the hairdryer. But to make it nice, instead of having some arbitrary distance, I can change the extent type to object instead. So it'll ask me to select an object, which is this one here, and then it will extrude right up to this face, right? Again, this hairdryer body is a more organic, complex shape, but the extrusion will kind of wrap around it, which is kind of what we want. So I think that looks good. Obviously, this handle is quite stubby, so I'm going to use the second type, or the second side for the extrusion to extend it. So, I don't know, I'll do like 150 or something. So once I confirm that, we have our handle. You can see the inside of the dryer right here is the same. There's nothing extruding into it, and that looks pretty nice. So that's good. Anyone want me to do that again? Just raise your hand. Okay. So I have my sketch here. The direction is going to be 2 sides instead of 1 side. For side 1, I'm making the distance to be the object, which in this case is the hairdryer's body. So it makes a nice flush extrusion. And then the other side is just some arbitrary number that I have. So I think I did 150. You want the operation to be join because you want it all to be one piece. And then you can just confirm it. That makes sense? Okay, sweet. The next thing on the kind of handle of the hair dryer, we have this chamfer here. So to add that, I'm going to go under modify and chamfer. It's very similar to the fillet tool, but instead of it being round, it's going to have a nice straight cut. That looks good. So who needs more time here? No? Okay. So now I'm going to go on a little bit of a rant on dependencies. So if you didn't know, down here in the timeline, right, you've been working with this timeline for a little bit. You can kind of see what operations we've used to create this part. One of the things that's very powerful about CAD softwares is you can change or reorder your timeline to, get a different result, right? So I'm not going to change, well, I will have to change this because I did it wrong, but you're not going to have to change much to get a different output. So let's say, for example, we've hollowed this out, but, we want to put electronics or something inside of the handle, right? You want to put a switch or something. You want it to be nice and hollow. So what we can do is we can use the shell tool that we had earlier, but we can make it apply to the handle as well, right? And the way we want to do that is we want to apply the shell operation after we've modeled the handle, right? So this is called the timeline for this reason, because all of this happens in a certain order. So if you change the order, it'll create slightly small differences in your part. But you can only change these orders if certain things aren't dependent on each other. So right now, I want to make this shell after, this chamfer here. So what you would do is you would select the feature and you would just drag it. But you can see I'm moving my mouse and it's stopping, right before that first fillet that we made. And it's because of the way I modeled it, the fillet is dependent on the shell to exist. So if we go back into this, I created a fillet on both edges, but this edge would not exist without the shell. So if I tried to move the shell to be after this, it would be impossible because it needs the shell to create the fillet. So it's kind of blocking me from moving the shell forwards. So to fix that, you have to remove dependencies. So in this case, I can't have this be rounded. So to change that, you can either delete the feature or you can deselect stuff. If you want to deselect stuff from your feature, you can hold down Control and then you can click on the thing that you want to be deselected. So now, this line is sharp from how it was before. And if I want to move the shell, it's going to let me now. You can see the line is dragging with me. And when I let go, and I rotate over here, you can see this area is now hollowed out, right? So this is kind of what I'm going for here. Now we can put stuff inside of it if we wish to. But this can be kind of important if you want to change your timeline later, right? If you ever move things but it's not letting you progress it, you typically need to find that dependency. In this case, for me, it was that fillet there. You can also see if I rearrange stuff like this. Let's say I make this fillet a lot larger. This fillet is so large that it breaks up that shell that we made earlier. But if we change the order again, then that kind of goes away. So this is just kind of showing you that the order at which you make your operations can sometimes be important, because, you know, I haven't added or removed any features here, but we have two, you know, different parts, right? So it can be very useful for later. Does that make sense? Does everyone like have this fixed dependency now? You didn't like select both edges, right? You should be able to move the shell. Yeah. All right, cool. I hope these rants are useful. I know sometimes they can be kind of boring, but they're like little tidbits that I've kind of picked up along the way. Hopefully it saves you some headache later on. But yeah. The last thing we're going to do for this is we're going to add this wire here, where we're going to use, instead of a loft, we're going to use something called a sweep. They're kind of similar in the sense that you're creating, you know, a solid body from, you know, several sketches. For the sweep, there's something called a profile and a path. So the profile is kind of the thing that you want to be extruded along the path. And then the path is, you know, the path for the profile to follow. So you can see there's this circle here. That's going to be our profile. And then this kind of squiggly line is that path that it's going to follow. So I'm going to create another sketch here. I'm going to make the path first. So what I'm going to do is I'm going to select this plane right here. And then it's going to kind of go straight down the middle of this this handle, right? Another reason why I like basing things off the origin, you know, you like to cut things in half a lot, or you like to have planes in the middle of things. So if you create all of these sketches based off the origin, it typically makes it easier, right? Like if I made this the body of this all the way over here, I'd be spending a lot of time making a bunch of extra planes that I kind of didn't really need to make. So I'm going to select this one here, and then I'm going to draw some lines. One of the nice things about Fusion is that you can do something, or you can use something called a projected line. So you can take geometry that you already have, and you can kind of bring that into the sketch that you're making. So in this case, you know, I kind of want a line kind of going off the center of the handle body. So I'm going to project a line onto the sketch. So I'm going to press P, which is the shortcut for projecting. It's going to ask what geometry I want to select. In this case, I want to select this circle here. And, you know, because we're on this vertical plane right here, that circle will be translated into a line onto that plane. So when I press OK, it'll create these purple lines. If I hide the body, you can kind of see it a little bit better. So that can be pretty useful. In this case, you know, I want to make a line that's in the middle of this. So, you know, I can make a line here. And then I can make this point a midpoint on this line. So here, it's going to be a midpoint. And then let's say I also want this to be perpendicular. So I can apply that. Right. So that helps, you know, using that projected line will help me constrain other things. And then if this projected line was to change for whatever reason, right, if I, you know, change the dimension of the chamfer, all of these dimensions would follow, right? Especially because this is a midpoint, it'll just make sure that this wire is always centered on that body. So the next thing I'm going to do to make it look a little bit more organic, I'm going to use the fit point spline tool. So I'm just going to kind of click away, make a couple different paths here, and then just press that check mark. Once I'm finished, it'll make it look a little bit more organic. But I want this to be a nice smooth transition. So I'm going to make the spline and this line tangent. So it's a nice organic curve. And this looks pretty good to me. I'm not going to fully constrain this because constraining splines is kind of annoying. So I'm just going to leave it for now. It's a wire. It's nice and organic. So I have this. I'm going to create my path, or I mean my profile now. So I'm going to make a sketch on the face of the hair dryer. And then I'm just going to make a circle that's nice and concentric. I'm going to make these two concentric. That looks good. Okay, so you can see here, I'm going to hide the body again. We have this, circular profile, this line and spline path, and now we can create our sweep. So right above the loft, the sweep tool is here. We're going to select the profile, which is that circle, and then the path, which is, that squiggly line. Okay, so it's mad at me for some reason. It's probably mad because this curve is really aggressive. So I'm gonna edit this. Maybe pull this point out a little bit. And then I made this vertical line constriction as well, just in case that was confusing the spline. I mean the sweep. There we go. That looks good. Yeah, we have our hair dryer. We have our wire. That looks good to me. Let me double check. It may have been that vertical line. Oh, okay, I guess not. But yeah. Does anyone want me to do that sweep again? Okay. So I'm going to create a sweep. The profile is the circle that I'm after. And then the path is this one here. Looks good to me. And I just press OK. Any other questions? Yeah, I think of it. Yeah, it's on. I guess it's kind of a file. Yeah. I know some people, I think, have to leave early today, so I'm going to talk about the homework real quick. So I encourage you to listen up because, in my opinion, this is the most difficult homework assignment of this class. I think a lot of people have challenges with this, and it can be a little bit time consuming. But in my opinion, it's good practice because sometimes you're going to be creating some insane sketches when you make stuff. So your homework assignment is to use constraints to replicate this drawing that I'm going to be showing you in a little bit. Basically, if you're unaware, this is an aluminum extrusion. It's a pretty common, art that people use, especially when they like making things that are like modular, because these channels here have rooms for something called a T-nut, and then you can just slide in the nuts and then like attach stuff to it. So some people make like desks and stuff out of it. My 3D printer is actually made of T-slot extrusions, but it's a very useful like extrusion. They come in various sizes, but you can see here the sketch is a little bit more complex than what we've been doing in class. So your homework is to recreate this extrusion. This is one of the homework assignments that I do care about dimensions. So please use these exact dimensions. If you do it in inches or millimeters, that doesn't matter. But I want these numbers to be the same at least, right? So this photo doesn't have all the dimensions. So the next slide does have all of the ones that you need. This was modeled in SolidWorks, so you can't really take a screenshot and copy it, but it kind of gives you a hint of why or how you might want to do this, right? You're applying a lot of the stuff you learned today. Obviously, this isn't the finished sketch, but it has everything you need. So, you have these dimensions. You can see here when I modeled it, I created kind of this square, which has a bunch of construction lines, and you can use that as a foundation to create the rest of your sketch, right? So I modeled like half of this piece here, and then, presumably one would mirror all of these across this line here, and then circular pattern the whole thing, right? So it's kind of taking those things that you've learned from the gear assignment, applying it to this, and then, obviously applying a bunch of geometric constraints from that first assignment that we did. So again, this looks a little bit intimidating and, it might take you a while, but once you understand how to do this very well, you're going to be pretty much set because, like I was saying before, making really good sketches, making them nice and clean is, really beneficial for you later on, especially if you need to make changes, right? One thing I will say, some people get confused about these little radii. All of these, like these 3 radii, are all the same. So you can set these 3 to be equal. This one is different, right? But you can see the dimensions are labeled. This one has a radius of 0.35. This one has a radius of 0.1. If you use like diameter instead of radius, that's fine. But, if you use diameter, it should be double these dimensions. For the number of dimensions, you shouldn't need anything more than this, right? Especially if you have duplicates of the same number, then you can usually apply an equal constraint, right? So like for this construction square I made, I'm giving you kind of some hints here, but you can see I have one dimension here, 2.9, but you know, there's no dimension here, right? And it's because this line and this vertical line are both equal, right? So if you're seeing like two of the same number, you can usually set them equal and you won't lose points, right? Because I'll be taking points off if I see like zero point 0.1 like 3 times, right? If you make all of these 0.1, but you don't set them equal, right? It's kind of, in this case, I'm kind of implying that they should all be the same, right? Uh, some people have like multiple 0.7s or like 0.8s, and that will get you points off. So I'm telling you now, if you can avoid doing that, then you should be set. These little green like squares with little icons in them might give you a little bit of a hint. It's kind of hard to read because everything's so close together, but you can kind of see in general like what things have what constraints, right? Like this line here has a vertical constraint, right? There's a bunch of equal constraints because, you know, all of these radii are equal to each other. Lots of tangent constraints as well. So this might be a good hint for you, and please reference it. Don't reference this because it's missing stuff. So use this one. But yeah, if anyone has any questions about this assignment, please reach out early because we can give you some help and tips for this. But yeah, all of these slides again are posted for you to look at. So if you want to look at it again on your own time, they're there for you. You know, this recording or this lecture is recorded, so I'll post that as well. Unless I forgot to press start recording, which would be kind of sad. Okay, no, I didn't. Cool. But yeah, that's basically your homework assignment for this week. Again, I think it's probably one of the more difficult ones. So if you need help, please ask early so we can help you. But yeah, that's kind of it for this week. So I'll stick around for a little bit. But yeah, we'll see you next week. I'm losing my voice.
300 milligrams of caffeine, I'm still